Welcome back to your lesson 3.5. This is video number 2. So if you haven't watched video number 1, you need to go back and watch that. Okay, matrix properties. Let A, B, and C be matrices, and this brings up a good point. When you name a matrix, you use an uppercase variable. So notice that we have capital A, capital B, and capital C with the same dimensions, so they all have the same dimensions, and let K, lowercase k, be a scalar, just a number. All right, and so we've got the associative property of addition, and I've got a little typo there I'm going to fix because it's going to drive me nuts if I don't. Let me just fix it. All right, there we go. Sorry about that. All right, so associative property of addition holds. If you have A plus B plus C, you can add A plus B and then add C, or you can add B plus C and then add A. Commutative property of addition holds. You can do A plus B and that equals B plus A. And the distributive property, whenever you have are multiplying by a scalar, K times A plus B is equal to KA plus KB, and it works also with subtraction. Organizing data. Matrices are useful for organizing data and for performing the same operations on large numbers of data values. In fact, we're going to get a chance to see that in our next example. Let's go get one of the example PowerPoints, and we will look at examples 3 and 4. All right, we're going to look at a manufacturing problem because I want you to see why people use matrices. A company manufactures small and large steel DVD racks with wooden bases. Each size of rack is available in 3 types of wood: walnut, pine, and cherry. So there's a total of 6 kinds of DVD racks available: small walnut, small pine, small cherry, large walnut, large pine, large cherry. All right, sales of the racks for last month and this month are shown below. Okay, so last month you can see for the small rack sales there were 125 walnut, 278 pine, and 225 cherry. And then this month there were 95, 316, 205. Okay, and then you have similar information for the large rack sales. And this is on your note sheet. A little different format, but you have the same information. Okay, we want to organize the data using 2 matrices, one for last month's sales and one for this month's sales. So if you look, we're going to have to kind of reorganize here because they've got things organized according to the size of the rack. Okay, you've got one little table that's for small and one for large. Now we want to have matrices where one is for last month and one is for this month. So we're going to reorganize our data. Then we're going to write and interpret a matrix giving the average monthly sales for the 2-month period. All right, so we're going to organize the data using 2 3x2 matrices as shown. All right, it's 3x2 because we're going to have one matrix. Our matrix A is going to be for last month. Matrix B is going to be for this month. And each row is going to represent a type of wood. So we're going to have a walnut row, a pine row, and a cherry row. And then each column is either the first column is going to be for small units, and the second column is going to be for large units. Same thing for this month. You're going to have the 3 rows for the different kinds of wood, and then each column, one is for small units and one's for large. And now you just fill in the information. So you go and you look at your table and go, okay, so for last month, the small rack sales were 125, 278, 225. So you go fill those in the appropriate spot in the first column. And then you get the same information about the large racks. So there were 100 walnut, 251 pine, and 270 cherry. So that fills in our last month matrix. For this month, we go back and we look for the same information. For the small racks, it's 95 walnut, 316 pine, 205 cherry. And then for large, there's 114 walnut, 215 pine, and 300 cherry. All right, step 2, we're going to write a matrix for the average monthly sales. by first adding A and B to find the total cells and then multiplying the result by a half. Now normally when we find averages we talk about dividing by 2, but we don't really have division for matrices, so a way around that is by multiplying by a half, because dividing by 2 is the same thing as multiplying by a half. Alright, so we're going to have 1/2 A plus B, 1/2 matrix A plus matrix B. So we have 1/2 times the sum of the matrix 125, 100, 278, 251, 225, 270 plus the matrix 95, 114, 316, 215, 205 plus 300. All right, so order of operations tells us to go ahead and go ahead and simplify inside the parentheses. Okay, we want to simplify inside the parentheses. We can do addition inside the parentheses, so we're going to do that. So 125 plus 95 is 220. 100 plus 114 is 214. 278 plus 316 is 594. 251 plus 215 is 466. 225 plus 205 is 430. 270 plus 300 is 570. Now we're going to take that sum. We simplified away our parentheses. We're going to take what we got there and we're going to multiply by a half. And that gives us 220 times a half is 110. 594 times a half is 297. 1/2 times 430 is 215. 1/2 times 214 is 107. 1/2 466 is 233. And 1/2 of 570 is 285. Now, you might be asking, but can't we use the distributive property? Yes, you could have, but you would have had to multiply a whole bunch of things by a half, like that 125, and then in the next matrix, the 95, that don't come out to be something nice. You'd have to multiply things by 1/2 and then add. So it's much easier in this case just to follow the order of operations and not use the distributive property. Okay, so we still need to interpret the matrix from step 2. The company sold an average of 110 small walnut racks, 107 large walnut racks, 297 small pine racks, 233 large pine racks, 215 small cherry racks, and 285 large cherry racks. So interpreting means that you consider the space where the position of each element, and you say what that means. So since the first column represented small racks and the first row represented walnut, that's how we know that there's 110 small walnut racks. Okay, second row is for pine. That's how we know there's 297 small pine racks. And the third row is for cherry, so that's how we know that there's 215 small cherry racks. All right, let's look at example 4. We're going to solve the matrix equation for x and y. So first thing we do is we go through and we simplify the left-hand side of the equation. So we write the original equation. And then we go ahead and we add matrices inside the parentheses, because that's what order of operations tells us to do, to simplify what's inside the parentheses. So that's going to give us 5x plus 3, okay, because 5x was added to 3, and there's no blank term, so we just have to leave it as 5x plus 3. And then we had negative 2 plus 7, and that's 5. We have, I'll look on my notes here. We have 6 plus negative 5, and that's 1. And then we have negative 4 plus negative y, so just negative 4 minus y. And that's going to equal negative 21, 15, 3, negative 24. All right, on the left-hand side, we still need to simplify. We need to multiply everything by 3. So 3 times the quantity 5x plus 3 is going to be 15x plus 9. And then 3 times 5 is 15. 3 times 1 is 3. 3 times negative 4 minus y is negative 12 minus 3y, excuse me. Negative 12 minus 3y, because we're going to multiply everything by 3 on that left-hand side. And that's going to equal negative 21, 15, 3, negative 24. Now, one of the things that we talked about earlier was that for two matrices to be equal, they have to have the same dimensions, and we have that here. We've got a 2 by 2 matrix equals another 2 by 2 matrix, and then each corresponding element has to be equal to each other. So 15x plus 9 has to equal negative 21. Well, we move to the second column in the first row, and we get 15 equals 15. Well, that's true. It's just not interesting. We're not going to be able to solve for anything, so we move on to second row, first column, and we get 3 equals 3. Again, nice thing. It's absolutely true, but it's not going to. We don't have anything to solve for. So we move to the second row, second column, and we have negative 12 minus 3y equals negative 24. So we have another equation. So we equate corresponding elements and solve the two resulting equations. So we've got 15 plus 9 equals negative 21. So we subtract 9. That gives us 15x equals negative 30. Divide negative 30 by 15, you get x equals negative 2. Now there is another typo. For some reason, they like to put 2's when they mean negatives in these PowerPoints. Can you see the typo? Yeah, they did negative 21 minus 3y equals 224. That's not at all what they mean. They meant to do negative 12 minus 3y equals negative 24. Okay, so you add 12 to both sides, you get negative 3y equals negative 12. Divide by negative 3, you get y equals 4. So the solution is x equals negative 2, y equals 4. Okay. Excellent. Guys, you've got a few problems there to try on your own. Go ahead and work through those, and then we will go over those right when you get to class next time, and after that we'll get you started on your rounds and you'll get to practice all this, and then we will move on to learn more about matrices. Y'all have a good day. I'll see you soon.